Hello guys, this is Rao. Sorry I had to use this way to give this lecture, but first I would like to say, well, Happy Chinese New Year, and I wish you all the best for the year of the pig. Okay, last time we stopped at the Ohm's law, so today we're gonna talk about the power first. Well, power, as you may have already learned in physics, is how to say the energy at a unit of time, which is a second, right? So energy first. Let's see. Energy, which is W, equals to power, which is P times T, which is the time, as you can see here. And P, power, as you may have learned, equals to I square R, which is the square of the current times the resistance. Or it could be P equals to V squared over R, like this. So personally, I would say this P equals to I squared R, this one is used in parallel circuit, no, in series circuit more. Series circuit more. And this P equals to V squared over R used in parallel circuit more. Parallel circuit. Like this. Okay. Also, P has another expression, which is the most common expression, which is P equals to V times I. P equals to V times I. Now this is what we use the most in DC circuit to get the power. But let's see, like this two, now like this two. Now in series circuit, since series circuit, the current is equal everywhere, so it will be easy to use the current, right? And for parallel circuit, for parallel parts, the voltage is all the same, so it's easier to use the voltage. That's about energy and power. Also, the unit of the energy is joule, or let's say capital letter J. And the unit for power is watts, or in capital W. Watt. This is the unit of the power. Power measures the energy in a unit of time. And power times time will be the energy. Now, let's take a look at a small example first to calculate the power. Now here, I have a small circuit. Which the voltage source has 12 volts and the resistor has 6 ohm. The voltage source has 12 volts and the resistor has 6 ohm. Okay, find the power, P delivered by the source. Find power delivered by the source. Now, this is just a simple circuit, and as we have learned from Ohm's law, the current I equals to 12 volts over 6 ohm, which is 2 amps, right? This is the current of the circuit. And P, power delivered by the source, P would be V times I. And this V is the voltage of the source, and I is the current that goes through the source, right? Which is the 12 volts times 2 amps. That gives 24 watts. Like here. This is the power delivered by the source. So, just a small example of the power. Now, well, it's not the, how to say, it's not quite the power that we would like to, discuss the most right here. Because if you go home and check all the appliances at your household, you will find, for example, you will find a little tag on each of the appliance. Your television, your desktop, laptop, or I don't know, microwave, anything. It has a little tag with all the detailed, electrical information of this appliance. Now, for example, it will show a rated power and rated voltage. For example, a microwave, let's say. Rated voltage, let's say 120 volts. Oh, that's pretty much the, rated voltage for all the appliances in America. And rated power, let's, for example, 750 watts. Now, rated voltage, rated power for a microwave. First, let's talk about what the rated means. Now, rated means under rated voltage, this appliance would consume rated power, which means if we use 120 volts as the voltage source to power this microwave, the unit time, let's say 1 second of this appliance is going to consume 750 joule energy, which means, let me write down on the paper. Now, which means 1 second, let's say 1 second, consume 750 joules energy. 1 second consumes 750 joules energy. That gives W equals to 750 joules, and T equals to 1 second. So that P equals W over T, right? As we have know that W equals to P times T, right? So P equals to W over T, which is 750 joules over 1 second. That's 750 watts. right? It's just another way to calculate the power, but as you know, as it shows here. But you can always use the voltage times the current. Only we don't really know the current, right? However, we have rated voltage and we have rated power. We can, calculate the current under the rated situation, right? But it's kind of different. Anyway, let's get back to this one here. So, for example, if I use this microwave for 1 minute, let's say to heat your breakfast, let's put something in your microwave, heat it 1 minute. So let's see how much energy we consumed in this 1 minute. So that gives T equals to 1 minute, which if we want to do our calculation, T must be in seconds to match the units, right? Which means this is 60 seconds. And P equals to 750 watts, where watts is actually joules per second, right? That the unit of watts is joule per second. Okay, now W is the energy, equals to P times T equals to 750 watts times 60 seconds. 750 watts times 60 seconds. That gives here W equals P times T. That's 750 times 60. That gives how much of that? To 450. Yeah, that's 45 kilojoule. Right, 45 kilojoule. Let me double check. 0. That's what, 150 times 3. Yeah, that's 45 kilojoules. 45 kilojoules. That's how much energy that it consumes. However, that is not how the utility company charges us, right? I'm not sure how many of you guys actually pay your utility bill. If you in case someday you would pay your electric bill on your own, something I need to introduce here is how to, read your bill. Now, first, we have something that that is a measurement of how much energy that you use or how much energy they're gonna charge you. The unit of energy for the utility company is unit. Let's say unit. The kilowatt hour. Kilowatt hour. That's the unit they're going to charge you. And also, the unit price and the unit of the unit price is in cents per kilowatt hour. So unit price in cents per kilowatt hour. Cents per kilowatt hour. Which means if you read your electric bill, you're gonna see, okay, how much energy that they use in kilowatt hour, and what's the unit price. And they also have a delivery charge, which is something different. That's not part of this discussion, but the delivery charge is basically some maintenance fee. And this unit price is based on the, how to say, the cost of the coil, and some charges from the generators. Now that's quite different. But we don't really talk about how can we get this price. That's gonna be a totally separate course to talk about this, and that course honestly it's not easy at all, and it's not funny. Anyway, so which means the total cost is going to be in cents, right? And yet you may have, for example, $50 a month of the electrical bill. That's pretty normal, right? But if you know all the power of all your appliances at home, you will be able to estimate your electrical bill based on this. Now let's take a look. First of all, let's talk about the unit kilowatt hour. Kilowatt hour. That's actually set the unit of the power, P, set to kilowatt. P set to kilowatt, and time, T, set to hour. When P is in kilowatt and T is in hours, that's how we get this unit, kilowatt hour. So if we take this question as an example, now P equals to 750 watts, this microwave. In kilowatts, it's 0.75 kilowatt, right? And T equals to 1 minute, which is 1/60 hour, which is 1/60 hour, right? Okay. And now W, which is the energy, equals to P times T, which is 0.75 over 60, right? Because that's 1/60 hours, so we times it, right? So 0.75 over 60, which is, how much is that? 7, that's 5/4, right? 5/4, which is 1.25. Which is 0.0125 kilowatt hour, right? Now this is how much energy you use just for 1 minute of this microwave, right? Okay, now if electric price is 10 cents per kilowatt hour. 10 cents per kilowatt hour. So the cost would equal to 10 times this 0.0125. That's going to be what? 0.125 cents, right? It's going to be 0.125 cents, right? You know, unit price times the quantity. It's going to be the total cost, right? Okay, it's not even 1 cent, right? Which, you know, we assume it's just 10 cents per kilowatt hour. Honestly, so far, the electric price is, let's see, I think it's a bit higher than this, right? Unit price, I think it's a bit higher than this, but anyway, that's how much you pay, this 0.125 cents. That's how much you pay for using your microwave for 1 minute. That's just a microwave, but no, we can calculate something else. We can calculate something else. For example, just your, let's say your a television. Let's grab some of another paper. For example, your television. Let's assume the rated power of your television equals to 200 watts. 200 watts. And every day, we watch it for, let's say, 2 hours. Every day we watch it for 2 hours. Now assume a month has 30 days. 30 days. Assume a month has 30 days. Now, it's definitely not January or February, right? Or March. That's April, but for average, it's 30 days a month, right? Okay. Assume a month has 30 days. And the price is, let's set it to 12 cents per kilowatt hour. 12 cents per kilowatt hour. Now find how much we shall pay for just, you know, watching the television of a month. So first of all, still we do unit conversion. We convert it to kilowatt and hour so that we can do our calculation. Now P equals to 200 watts. That's going to be 0.2 kilowatt, right? That's going to be 0.2 kilowatt. And T equals to 2 hours times 30 days. That's how many hours you watch your television in a month, right? In total, that's going to be 60 hours. T equals to 2 hours times 30 days. That's going to be 60 hours in a month. Okay. Now, W is going to be how much energy, how much electricity that you consumed for this television. It's going to be what? P times T. That's going to be 0.2 kilowatt times 60 hour, which is going to be 12 kilowatt hour, right? It's going to be the energy that you consumed in a month. 12 kilowatt hour. Cost would be W times price, right? Which is 12 kilowatt hour times 12 cents per kilowatt hour. Right. At the bottom. Okay, cost equals W times price, which is 12 kilowatt hour times 12 cents per kilowatt hour, which is the price. Then that's the total cost. This one equals to 144 cents. Right here. The answer is 144 cents. Now this one is what? $1.44. Yeah, it doesn't matter. That's gonna be how much you pay for, watching the television 2 hours a day in a month. Or maybe you watch a little bit more. That, of course, you pay more, right? That's the thing. In the old days, we have some old electric meters that you have to read. Now, I think pretty much all the new apartments or new, new houses, they have the digital electric meters to read, which you don't really have to read all the ticks in a circle. That's way much easier. For how to read those old ticks meters, I need to just talk a little bit more for that. In case you will have to read it someday. Now, consider it's a circle. This has 0, 1, 2, 3, 4, 5, 6, 7, 8. No, yeah, it's not quite beautiful, but just to say. Okay, now if the pointer is in between 1 and 2, if the pointer is in between 1 and 2, it means 1. Means 1. It means 1. It means 1. Okay, let's say if it's between 8 and 7, means 7. If it's between 8 and 7, it means 7. It means 7. So always go for the number that is smaller than the pointer. Always go for the number that is smaller than the pointer. That's how you read this, old type of the electric meter or gas meter. Either way, don't make a mistake, because the utilities company is going to definitely charge you more if you gave a meter reading which is more than what it actually is, right? So just so you know. Okay, so much for that. That's how we do your electrical bill or read a electric meter. Something that is definitely important for your for your understanding of the circuit is the power source. As you have take a look at this, as you have known that this power source is actually delivering power to this resistor, which the resistor is a load, and the battery, let's say power source, is powering it up, right? It is delivering power. So which means let's draw a picture for this. Now if this is a battery. Now, if current goes this way, this is battery with E as the voltage. So if current goes this way, if current goes this way, so it goes out from the source, current goes this way. Or we can say it's from negative to positive. It's from negative to positive of the source, but either way. Now this is delivering power, the source. This source is delivering power. We may also have the opposite way. We may also have the opposite way. The current goes from the positive to the negative in this battery. Now this is actually, this battery is consuming power. This battery is consuming power. Can you think of an example of this? Now, what I could think is when you charging your phone, right? Charging your phone. When you're charging your phone, if this is your phone battery, if this is your phone battery, now this one, when it's being charged, it's actually like a load, right? Which means the current is definitely going to go from the positive to the negative. And basically inside your battery, there's a lot of chemical stuff. So with the voltage, proper voltage, your phone can be charged. Now in this way, it's acting like a load, and just remember that it's acting like a load, like a resistor, but it's not actually a resistor. But just so you know. Okay. Let me see. Anything else I need to cover for this part? Let's do a little example here. Just do it for real quick. Okay. What are the internal resistance and voltage reading of a 450 watt automatic washer that draws 3.75 amps? Let me just write it down. What are the internal resistance and voltage rating of 450 watt automatic washer that draw 3.75 amps. What are the internal resistance and voltage reading, which is rated voltage of a 450 watt automatic washer that draw 3.75 amps? This question means if we have a source E, and this is a I, This is R. This R is the washer. The washer. That's the washer. And P equals to 450 watts. Now, if we convert that description of this question into a circuit, this is what it looks like. Okay. And I equals to 3.75 amps. That's what it's talking about, right? Okay. We don't really know how to solve this question yet. Now, something we do know is P equals to VI, or equals to I squared R, or equals to V squared over R. Right? So how do we get it? And we need to find E and R. Where in this case, E equals to V, V equals to E, right? I mean, they're the same. So, you know, we have equation. It's the resistor, or the resistance and the voltage that we don't know, right? So since we have P equals to I squared times R, we know current, we know power, so we can find resistance, right? So gives us resistance R equals to P over I squared, right? P equals I squared. And if you plug in the numbers, that resistance is 32 ohm, right? Resistance, it's 32 ohm. Also, we have P equals to VI. That can give us V equals to what? P over I. Right? V equals to P over I. Right? Now plugging the power and the current, V equals to 120 volts. V equals to 120 volts. Right? Okay. That'll be it for all the power. And if you have any questions, just send me an email. I will post the notes from previous semester so that you can compare it with this video, and so that you can check it out. Okay. And thank you so much, everybody, and I'll see you later.